So, g'day everyone. I originally come from Australia. My name's Nick Harris. I've moved to Redmond and I've taken on the role of technical evangelist for Windows Azure. So I get to work with cool guys like Wade and James and Nate and such. A lot of other guys there that are awesome, but too many to list. So today we're going to talk about application scenarios. So when you think about the types of apps you can write for Windows Azure, there's actually quite a broad variety of apps that you can go and write out there. So some may be web-based applications. You may have a keen interest in technical computing. You may be writing device applications and leveraging cloud-based services to power them. Or you may be building out social games or social apps. So today we'll go and walk through these scenarios and have a look at some of the key tooling that we've created for you guys to use. So we'll start with web. So James has already given you a great introduction to the web role. So this is where the web story all starts. But you may be out there working in enterprise or in your own businesses, and you may have, for instance, existing applications. So one of the web scenarios is the brownfield scenario. So brownfield scenario, take for instance, you have a standard ASP.NET MVC application. So this is here, it's not a cloud project. This is a pretty stock standard simple one. So I'm just going to show you some of the quick steps that you do to convert that into a cloud project. So we just go off first and add a new cloud project, and then we'd reference that web role there. Optionally, if we wanted to, we could go and add the web role.cs there, which implements role entry point, which allows you to go in and perform some actions by overriding on start, run, and on stop, if you wish. But that's somewhat it. There are some other key considerations which we'll walk through for web applications, such as what you do with state and identity and such. But we'll get to them in a minute. The one last thing you may need to do in this scenario, particularly when you add your web role, is when you add your web role CS, which is implementing role entry point, is to go and add references to these guys, otherwise you're not going to be able to build. You may want diagnostics, so you can just go and add a simple listener in there like that. So that brownfield, migration up to the web is not too difficult, particularly if you don't have any dependencies on perhaps third-party applications that need to be installed that may require manual intervention. In that case, you would go out and look at what's called a VM role. But let's have a look at greenfield applications. So typically, most web greenfield applications start with a single web role. And then users will need to perhaps go out and store some images and things like this. But really, at the moment, the way we do things here with Windows Azure is we allow you to focus on building your apps. So build your apps, deploy it up into the cloud, and we manage that for you. But if time to market really matters, and you've got some really simple web applications, you can utilize some of these CMS partners. So these CMS partners here, Umbraco, Kentico, Sitecore, Orchard CMS being a Microsoft one there, will go and run up on Windows Azure. So once you've decided whether you're doing truly greenfields or using a CMS, first thing you may do is say, I need to show some images in my website. So the perfect place to store those images or other media of binary type, say a video or some XML or documents, is to utilize blob storage. So Wade's walked through with you and gone in depth on blob storage today, but I just want to call out that that's typically where you're going to store these things. Now, what about information like about people and those sorts of things? Well, you can utilize table storage for that. But if you come from a SQL background, you may want to utilize SQL Azure. Now, if you go out and use SQL Azure, all that existing knowledge that you have in terms of being able to go out and write T-SQL stored procedures, write queries, utilize Entity Framework, all these things are directly transferable up to SQL Azure. In actual fact, there's only a few small things that you'll find that are slightly different. But typically, the transition is very easy. So, after I've gone and dealt with images and storage, you may be thinking, okay, now I need to start to deal with scale. And Wade's walked you through scale in the last session. But what you'll typically do there is start scaling out for multiple web roles. Then you may take an interest in performance and go and utilize the App Fabric cache to go out and cache those static data sets such that you don't have to go and hit disk again to perhaps retrieve a product lookup. So Wade gave you a great example of how to utilize cache and store some data in a key within the App Fabric cache there. So that's cache. And then the last thing which I typically add is authentication, because as a developer, I somewhat don't like to go and sort of log in my sort of tight dev cycles when I'm making changes, hitting F5, and then, okay, now I've got to log in again. So I add ACS last. So that's a pretty standard greenfield scenario for 90% of websites. But some websites will want to do more. They may want to go and do something based on an action that the user's performing, and they may want to manipulate some data. So you may find that there's some event that occurs in your web role. It may be a user calling into a WCF REST service. It may be a user triggering action on the web role, and they'll go off and they'll dump a little piece of work into a queue. So this queue is a way that you can go out and offload some long-running task to be done by a worker role. So in this case, you can offload your work to the queue and then have a worker role sit there and go and pull this item off the queue to process that work. So think perhaps video encoding. Once you go out and start doing that work, you may retrieve some information from table storage or SQL, Azure, even blob storage, and then just go and write that back. So that's offloading your work with an async process. So some of the key considerations that both green and brownfield applications running up in Windows Azure have to consider are these: identity, stateless, multi-tenancy, and deployment. So we've covered identity quite well in Wade's last session, so we'll be quick on this. But the key point to note is you do have these three options. You can create your own. You may go and use ASP.NET membership. That will require the end user to go out and create another username, another password. So what you really need to be thinking about as well when you're thinking about identity is make the end user's life easy. I don't realistically want to go and remember 20 separate passwords for all the websites I'm using. I may want to go out and use, say for instance, my Live or Facebook ID. But where the power of ACS comes in is in that last one, where you can outsource the entire identity management and give the user the choice to not use just a custom membership provider like ASP.NET membership or utilizing a single one, but they can go out and use something that they're comfortable with, be it their Live ID, Google, Yahoo, or their corporate credentials. So moving on to statelessness. Now, you need to understand that when a request comes into a web server up in Windows Azure, and you may have 2 instances of a web role, that request will be routed out to the web role in a round-robin fashion. So what this means is, on your first request from a particular user, that request goes to, say, server 1, and then the next request will go to server 2. So if you're storing any state locally, then you've got a problem, because the first time you hit server 1, the state will be retained there, and then when you hit server 2 again, the state's no longer there. So you need to follow web farm best practices. So let's look at a diagram of this. So here I am. I'm going to go and request something from a website, and I'm going to, in my code in my website, store something in session. Now, if I'm using in-proc session state here, it's going to go and write it to this web server in the little orange dot there. But then I go and hit the site, perhaps navigating to another page where it needs to pull that session out again. So in this case, I've actually gone there, and I've gone and updated the session state. So I've set it to 2 here. So now you can see we've got 2 pieces of session state in different values on those different servers. So what's the value of foo for this particular user? Well, it really depends on which server he's sent to next. It's 1 here. It's 2 there, it's nothing over there. So we need to think of externalizing this state. So to externalize this state, we've got 3 options here. We can utilize the Windows Azure App Fabric cache. So there's a provider there which allows you to externalize that session state directly to the cache. That's great if you want in-memory and fast. You can go and put it out to SQL Azure if you want to make use of that existing resource, or you can also utilize the providers for Windows Azure storage. If you want, you can persist it to a client cookie. So they're the options that you can use to externalize your state there. But one thing that a lot of people tend to forget is in ASP.NET MVC, temp data actually uses session state. So if you're going and doing a search for session everywhere, don't forget to check for this one too. Right, so that's statelessness. Now, what about multi-tenancy? So you guys are there and you've got an application and you may be able to write it in a way such that you can have multiple tenants using that one application and the one deployment of that code base. So let's have a look at this scenario. Let's say I'm tenant 1 and I've browsed to tenant1sasservice.com. Now, on the web server, we've only got the one deployed instance of that code base and we've scaled out multiple instances of our web role. So what's happening here is we've resolved that host here and said, okay, it's tenant 1. We want to utilize tenant 1's DB because our tenants don't want to share different SQL Azure DBs in terms of data. They don't want the data partitioned horizontally. They want their own SQL instance. So in this case, we've resolved tenant 1 and sent him to his database. Now what about tenant 2? So tenant 2 hits the server, and then we resolve the tenant by examining the host header again, and then we route him off to the appropriate database. So the key thing to consider here is by having one code base that is multi-tenant, you're able to on-sell this to those multiple tenants, but service all of them from the one deployment, which can be scaled out to however many instances you need based on their demand. So to do this, it turns out it's actually pretty simple. So this is our service definition. Now, in that particular example, we had one code base for these tenant 1 and tenant 2 clients. So you can see that in our service def here, we've got a sites node, and we've got multiple sites within that. Now, our physical directory points to multi-tenant app1, and that's our compiled ASP.NET code. Now, to set up the host headers, it's also quite easy as well. So we just go and specify a host header for each of those, and then we know when we get a request hitting this deployed web role, it'll look at the host header and then route it to the appropriate code base. But that's multi-tenancy, but what I also wanted to call out here is that you can make your deployed web roles multi-site capable. And that's what I've added this last one in the bottom for. So consider you can have a particular web role and you can go and deploy 5 different websites on there if you so wish. So to do that, it's just simple again, point it at the appropriate directory and set up a host header for that particular user. So that's multi-tenancy and also multi-site, and it's all done within that particular service definition there. You do still need to write the code. Right. Yep. This is dynamic in the sense of you deploy this up into your okay. Yep. So it's dynamic in the sense that you package it and publish it up into Windows Azure. You can't change the service definition at runtime as such unless you do, with the new in-place upgrade, there's some stuff there. I can show you or refer you to a blog on that. So let's just go on to startup tasks. So multi-tenancy, session state, startup tasks are also something that's quite handy, and you did see James gave you a demonstration of installing PHP onto your web role. Now, to do that, it's actually quite simple again. It's just a small customization in that service definition, but what it allows you to do is to script out any custom configuration for your web role. So you may have some code there that requires particular registry keys to be set. In the PHP example, we wanted to run web platform installer to go out and install PHP in for iOS use. So to do that, we'd probably go and set a path here on the command line to our script. Our execution context would be elevated, and we'd use a task type of simple, which means that our web role will not kick off and, I guess, be hooked into the load balancer until PHP is installed, because we don't want requests hitting our website before we can actually service them, using the PHP engine. So that's that. Now, deployment. So there's multiple ways to get your content up there and keep it up to date. So James showed you how to package a website. generate that package, and upload it through the portal. But you can also publish it directly through Visual Studio. So those of you that are developing and wanting to just publish to the cloud, you can just right-click, publish, and push it up. You can also utilize Web Deploy to push up your changes fast. But you do need to understand that that's not going to be persistent if the role recycles. You can do in-place upgrades through the portal, VIP swaps, and I'd probably recommend if you're doing one instance and you just want it to be fast while you're developing, not for production, just use Web Deploy. And if you're, again, developing on multiple instances, well, then you can look at the Windows Azure Accelerator for web roles, which allows you to push that change to multiple instances without having to actually connect out to each one. So that's web. So what about technical computing? So when I talk about it is a technical word. When I talk about technical computing, we're talking about things like digital media rendering and encoding. So think of Pixar films. To go out and render those films takes a significant amount of time, particularly if you're doing it on one machine. So you need to be able to, push these out into big compute clusters to go and achieve these large tasks in a small amount of time. And each of these workloads here are those types of tasks that take a particularly long time to process a huge amount of data. So earth sciences, you may be processing some data relating to earthquakes, data analytics, engineering, modeling, and simulation, perhaps looking at airflow over aircraft and simulating these things. So the problem is quite simple, and we just briefly touched on it. Some apps or solutions are going to run slow if you're using, one computer. So the goal is split it up into chunks and process small parts of that. So we talked about web role. Now, technical computing, typically the worker role, which James also showed you, is the way to do this. So a worker role is something that can kick off with a non-start. It can run and process work forever until it's stopped by you or it's recycled. Now, when we split these up into chunks, we need an efficient way to be able to go out and manage all these nodes that we've got out there that can go and do this work. So we need what's called a compute cluster. Now, we need this, but we also need tools to create and manage this cluster. And we need a scheduler to keep the cluster busy such that you don't have machines that are just sitting there doing nothing. So what we've actually got for that is we've got the Windows Azure Scheduler in HPC Service Pack 3 training kit. And what that's got is a job scheduler, and that's got a job submission API and portal. It's got queue, which allows you to go and prioritize items, and resource sharing policies. Within this training kit, it's also got examples of how to go out and do technical computing in terms of processing data or information using parametric sweeps, MPI, cluster SOA, and link to HPC. So this is a look of what the Windows Azure Scheduler actually looks like. So you can see that we've got a management role. So this is a worker role. Let me grab my mouse pointer here, sorry. Just trying to find the right screen. So we've got our management role here, and it's got a Windows Azure Scheduler on it. It's also got a web portal with a REST API. So what that means is it's exposing some means for us as someone sitting down in this room, sitting on a mobile phone, to go out and schedule some work to be done. So the scheduler actually, its role is to go out and push out these work in chunks to each of the individual compute workers, which go and process their small portion of work and then push it back into table storage. So I'm going to show you a video of that in action. Let me just trying to get the video going here. Is that playing up there? Oh, there you go. Yep. So in this case, we're just rendering the web portal, but we could quite literally be calling the REST API. And we want to go and render some frames of an actual three-dimensional model and having Airflow push over that model and see how it's reacting from different angles. So that's gone off and it's pushed out a job to the scheduler to go and render those frames. So you can see one frame's already been rendered and put into blob storage, and there goes the other one. And then once that has occurred, we'll then be able to go and view what that looks like. So let's take a second here, and there we have 2 frames of that particular problem. Obviously, 2 frames is a small example, but as you can understand, as you want more and more frames perhaps sweeping over that vehicle, at a smaller angle, then you're going to need more compute to be able to go out and do that in a short period of time. So let's talk about devices. So there are a lot of devices out there on the market. We have Windows Phone, Android, iOS, Win 8 developer preview. And when we go out and start building applications for these, we need to think, if we're going to engage the users, are we just going to go and perhaps build a local isolated application that just functions on a device? Now, by all means, there are a lot of good applications that you can create like that, but there are also a large number of exciting scenarios which you can start creating if you start utilizing some form of service tier to allow your users to interact and communicate with each other. It may well be that you may not want them to just interact. You may want to offload, from this low compute device, some big task for the cloud to go out and process for them. So let's have a look here. So common scenarios as far as devices are concerned require use of storage, identity, communications, be it device initiated or cloud initiated, and then perhaps when the device application becomes more popular, you may utilize those other platform services like Traffic Manager, CDN, and such to allow you to scale for a huge user base. So we've already had the storage session in depth, so I just want to recap what those storage options were that we can try and leverage from our device application. So we've got table storage, blobs, queues, and SQL Azure. But there's one thing you need to be really careful about when you're leveraging storage from the devices. From a website, it's reasonably safe because your website is deployed up in a data center and any configuration you have for that is hosted there. But once you start dealing with devices, if you're trying to leverage these resources, you may be inclined to perhaps go out and put some of these storage secrets like your SQL Azure username and password or your storage account name or storage account key on the device. Now, the first problem that creates for you as a developer is that someone may compromise those quite easily and then go off and utilize them to use your storage account. So the key thing here is don't put your secrets on the device. We need to protect them. You don't want someone taking your storage account name and key and utilizing your 100 terabytes of data to do whatever they want with it. So just to show you where these would be found in the portal. So here's a storage account, and that's the storage account name, SANIC, and this is the storage account key. Don't worry, I'm not sharing it with you guys. I've actually gone and regenerated those keys, so you won't be able to go off and use them anywhere. Someone here has a photographic memory. Okay. So that was storage account, but here's your SQL Azure connection strings. So, you don't want to be giving away the server location, the public endpoint, username, password. This isn't so much of a problem because of the way SQL Azure allows you to go and set firewall rules that allow IP to IP restrictions. But it's still not something that you want someone to get, because if they can get into one of those allowed ranges, then they're going to be able to then connect. So don't share it, otherwise it's no longer a secret. So how do we go and protect these things? So these are some patterns that you can utilize in your applications to try and avoid these keys being compromised. And most of these patterns require a proxy type pattern. So in this case, we're going to look at how one way that you could go and push a blob, be it an image or a video, up into blob storage. So to do this, what we do is we have our device, we take our photo, and then we're actually pushing the whole physical image up through the web role. The web role has our storage account name and storage account key. So once that image gets up there, it's then proxying it in to the storage account. And in this case, our keys are safe up in that web role, they're not on the device. But this isn't particularly the best way to utilize a web role and blob storage. We do actually have something that's a bit better, and I'll explain why in a second. So let's have a look at the alternative. So in the first alternative, we uploaded that whole blob, which may be an image, a couple megs big, maybe a video, 10 meg, 20 meg, or larger. And if you're trying to upload that through the web role, you're going to start inundating that in terms of its capacity. So each physical machine does have a specific bandwidth per second that it's allowed or that it can utilize. And if you're pushing things like images or video through that, you're going to find that you're going to have to scale out more and more just to handle those requests. So what we do is we utilize what's called a shared access signature. So Wade's touched upon this. Essentially what it is it's a request that goes to your web role. You're authenticated against that web role already, of course, and then it will return you a time box token that gives you access directly to write to your blob storage. So in this case, I've said, okay, I need to write something to blob storage. Can you please give me an access token? Web role sends that back. Now, the device can write directly to blob storage. So immediately you've gone from needing to push, if we're talking about one user, say a megabyte of data through the web role, to only, however many KB it is, just to request and send back a token. So this is quite important when you start thinking about capacity planning. This is going to save you, a lot in terms of that. So you won't need to scale out your web tier so much because you're not going to be hammering data through it. You're going to be going direct to blob storage. So obviously after you upload it, you can also pull it back down if it's a private container and you've been given access to that. So I should mention that if you do have a private container with data in there, the token can give people access to that for a period of time to read or to write. So let's talk about SQL Azure. So SQL Azure is quite similar in terms of same proxy pattern. We make a request to the web role. The web role stores the username and password for that particular SQL DB. Goes off, perhaps fetches some information from the table, pulls it back, and returns it to the user. So I think that's pretty clear in terms of how to utilize a proxy and how to offload the storage of those secrets to a role in the cloud. So while we talk about this, there's one more pattern I'd like to call out, which is offloading work through queues. So you can consider this a means by which you can have, perhaps it's a very complex calculation for gameplay. If we're using a game example, your device may not be able to calculate that very quickly on its own. So you want to utilize the power of the cloud in this case to go off and perform that calculation and figure out what the move should be. So in this case, you can offload perhaps just the data for that calc into a queue. A worker role can grab that information, process it, and then do something with it. So that's offloading work through a worker role. Right, so authenticating users with ACS. So this is the identity part of our device scenarios or common device scenarios. Now, Wade's sequence diagram was actually quite good, so we'll go through this a bit faster. But essentially, from the device side of things, it's just the same as the website BlobShare. BlobShare is just a client, and clients can be configured to utilize ACS. Now, in this case, we're just, our device is a client, and we've already got ACS configured, and we've gone out and requested a list of our identity providers. Now, you can see in this case, we've configured it for Live, Yahoo, and Google. And on the device, his scenario there, he selects Windows Live, and then we go out and hit Windows Live. And then now we've got the Windows Live login rendered, and we can log in to get our token back. So once we get our token, we go and pass that off to ACS and get our simple web token back, which then we can use against subsequent requests to our web server. One such request may be the registration process. So that's identity. Communications. So we've covered storage. We've covered how to, keep your secrets a secret. Identity. And now one of the key things for devices, particularly when you're developing those connected scenarios, is comms. So two ways. I can be a device initiating an action, so that's device initiated. I could be the cloud initiating an action to the device. So some event may occur in the cloud that the cloud wants to notify the device user about. So this is a scenario that isn't used so much, but it actually allows a lot of interesting application scenarios. So let's first look at device-initiated communications. So from the device side of things, we've got simple HTTP requests, so your HTTP request response. You can go and program out with frameworks, WCF, data. And then you've got a number of choices as to how you serialize that data to and from the device. Now, I'd like to say the most important thing on this slide from a device scenario is your wire format choice. So what I did here is I recalled a blog from Rob Tiffany from quite some time ago, but it was a really good analysis. And this is an analysis of a few different serialization mechanisms. And this was just for 8 users. So I'm going to show you the first one. So this is OData, and this is 8 customers. And that's size 1. So I understand you can't read it, but I've done this just for the effect of, understanding the differences between these different serialization strategies. So this is an OData response, 8 customers. This one here is WCF REST with XML response. So it's getting a bit better. We still can't read it. I can sort of read it off this one, but not off the other ones. And then what if we used perhaps JSON? Well, there you go. It's pretty obvious just by looking at those images which one of these serialization strategies reduces the data set significantly. So let's have a look at it. 8.5 KB, 1.2 KB, and 639 bytes. So does anyone know, what gain that is? Take a guess, a stab. Call out, is it 10-fold, 4-fold? It's 13-fold. So this is 13 times more efficient than that as far as pure data is concerned. Now consider that you've got a web role that has a limited capacity in terms of bandwidth per second that it can utilize. You've just increased the number of sort of requests that can be going to that in terms of the data flow by 13 times. So you've reduced your cost by 13 times as well. So that's important when you start scaling out. Maybe not with a small solution, but when you start getting, tens of thousands of users, it's quite important. Right. So I think this session was scheduled to go till 4, which was 75 minutes. So we're making good time, so we may have a guest come up at the end as well. So let's keep going here. So we talked about device-initiated communications, and the key point there being, serialization strategy is very important. Now, what about cloud-initiated communications? So what I'm talking about here, in most cases, it's push notifications. So is anyone here a device developer for WinPhone, Android, iOS, any of these devices? Right. Now, have you utilized push notifications? So I'm talking Toast, Tile, Raw. Okay, so no one's used this as yet in the room. So it's actually quite an interesting scenario. So when we talk about Toast and tiles, we're talking about those tiles on the screen of the phone device. So on Windows Phone, you have a tile, and a tile can have a background image change. So let's think of perhaps a weather scenario. You've got a weather app on your device, and you want to know what the weather's like in your local area. So there's a few ways you can interact with that user. In terms of Windows Phone, those notifications are Toast, so that's a message that pops up, a bit like the Outlook pop-up when you receive an email, but it's across the top of the screen. You've got a tile, which is image-based, and that can convey a changed image. Perhaps it's from sunshine to rain. And you've also got RAW, which is a mechanism by which you can push raw data direct to your application if it's running. So let's have a look at the patterns for these guys. Before we get there, we'll just enumerate the different notification services that you need to consider for multi-device scenarios. So Win8 Developer Preview has a Windows push notification service. Windows Phone has a Microsoft push notification service. Apple and iOS and Android have their own as well. So the common pattern used here is this. So star NS is, in actual fact, all of those notification services. First, we need to request a channel. That's a means by which we can uniquely identify a device. And the vendors provide a particular API which you can call in to get this channel. That channel will return, and then we need to put that up into our cloud service such that it knows how to address us later on. So we send our channel URL to our web role, and then we store it up there. So now let's consider this is our weather app, and there's been a hail or thunderstorm warning. Our web role may have been sitting there, and an event's been either entered through a web UI, or we've had a worker role sitting there hitting the Bureau of Meteorology, and we've determined that this is important. So our role has picked up that channel and then said to our notification service, tell our user that something has changed that they should be aware of. And this is where we can choose those different notification types. So that's a cloud-initiated communication. So in this case, it may be a toast saying, warning, get your car under cover, there's hail coming. Now, the other scenario here is, so that was more toast-wise or tile-wise, but what about if the application is in the foreground, it's running, the user's clicking through it, you can't really see the tile, you could send a toast, but what we do is we'd say, okay, web role, we're going to send out that again, but this time we're sending it using a raw notification type. So we're just sending an XML payload. And that will then be telling him, something's happening, and the device may go out and hit the web role and say, thanks very much, I've got that, you don't need to tell me again. So that's that particular scenario for cloud-initiated communications. So in the scalability talk, Wade walked through these, but I'm not going to enumerate on them again, but what I'd like to say is when you do start getting a large user base, you can consider these options to allow your services to scale out globally. And that's important if you want to be able to retain that user base and not have them having, say, a laggy or slow application, giving them an experience that they don't want to continue on with. So how do we make it easier for you guys to go out and do these things? Well, Wade's been working away building this Windows Azure toolkits for devices. And we've got 3 independent toolkits there that utilize the same common set of services up in the cloud to allow you to play out these scenarios. So this means you've got one Windows Azure deployment up there scaled out to however many instances you want. And that's one code base. That's it. It's done. Now all you need to do is deal with the client side of that. So in each of these toolkits, we've actually implemented samples of how you can leverage these cloud services. So I'm going to jump to a demo and show you the native toolkit experience here. So has anyone utilized these toolkits before? Okay, cool. So, let's do this guy. Duplicate. So, I've got Visual Studio here, and when you go out and install the toolkits, in this case I'm demonstrating Windows Phone, when you go out and install the toolkit, what you get is these extra application templates within your Visual Studio experience. So I'm going to select to use a new Windows Phone application. Going to hit OK on this guy. And now the first thing that needs to happen is, okay, if we're going to go and generate all these code and reusable services for you, we need to know where you want to store your data, what notification services you want to need, what authentication strategy you'd like to use. So in this case, I'm going to say I may just want to use Windows Azure Storage. So I click this, and then it's asking me, okay, so you want to use Windows Azure Storage? What's your account name and key? Because we need to configure your config file such that it can talk with it. So in this case, I'm just going to use the storage emulator. Next, I want to define what notification services I want to use up in the cloud. And I can go and say Microsoft Push Notification Service or the Apple Push Notification Service. If you're an Apple developer, you'll see here, and if you're familiar with notifications, this is where you go and specify the certificate to authenticate against that service. But we're just going to stick with WinPhone here for the moment. Identity, so do we use ASP.NET membership for our application, or do we outsource our identity to ACS and allow it to provide back the configured list of identity providers that we want to use. So this is, in the last session, Wade said I'd demonstrate this, so I'll give you a quick look at how we do this. So to do this, you need an ACS namespace and management key. So to get them, it's quite simple. In the portal here, I've selected access control, and down here, selected access control there, and we've got a new namespace created. So in this example, I'll use Nick Harris. So once we've got the namespace name, we then need a key to be able to go off and configure this remotely as part of the wizard, utilizing a whole heap of scripts. So if you're developing solutions out there, you could use something like this, but if it's just the scripting to be able to configure your ACS namespace, then you can utilize these PowerShell scripts to go out and automate that. So it's going to give you a large time savings. You're not going to need a person to go there and click through it every time you want to go and have it configured. You can just run a simple script. So this will utilize a script. So I've copied these guys in here. And that's our configuration done. Now, the actual PowerShell scripts we talked about will go off and configure that for us, and we're going to generate the entire solution. So this takes a little bit, particularly on my machine. My solid-state drive did crash, so it's just a regular drive there now, so things aren't snappy, but you can see at the moment it's just finished configuring ACS, and now it's generating my solution there. So you can see we've got our cloud project, we've got our phone project, and our web project. So in our web project, there's a whole bunch of reusable assets. So one, for instance, would be a shared access signature service. So this is something that you could utilize in your own applications to implement that pattern for going out and requesting a token and then uploading a blob directly. So let's just get started straight away and hit F5 and run this guy. Right, so while that spins up, bring up the device emulator, and here's my website. So the first thing to note is everything in this sample is using SSL, so we're not transmitting any information in clear text. But because we're doing this locally, we've had to utilize a self-signed certificate. So I'm just going to click through this warning here. I'm going to spin up that client application at the same time. So there you go. You can see it's gone out, hit ACS, and now it's come back with my list of identity providers. I'm going to utilize Windows Live to log in. And I didn't have time to create a demo account. And then, yeah, so the password shows in clear text in the emulator, so I'm just going to, oops, let me just extend for a second. Otherwise you'll go in and grab all my email. But if you like, that does have over 6,000 unread emails, which you can read for me and tell me which ones are important. It's like one of those accounts which you've had for years, and then you end up getting spam from all different sorts of places. Right. So bear with me 1 second here. I typed my password wrong. Even though I can see it, I didn't actually pick up on it. Okay. Sign in. Right. Sorry. I keep hitting Windows P, which dumps me out of the emulator. Okay, here we go. So we're signed in now. And you can see that we've got a pivot here which just has a few different options. And we'll start with the notifications option. So if I log in over here, I'll show you the web portal as well. The password for the web portal's within the documentation, which I obviously haven't read. All right, so let's start with push notifications. So this is a cloud-initiated communication, which we just talked about. So let's enable it from the device. So the device is now reaching out to MPNS and saying, give me a channel. It's going to get that channel and then go and register it up with our cloud-based service. So let's give it a little minute to do that. Yes. Doesn't look good. Oh, that's just the website, so it would have been blocking this guy. So that's okay. Not sure what's going on there. Let me just sign out and sign in again here. It's not the best. There. Looks like it's having issue connecting to my local storage account. All right, I'm just going to just proceed without doing this particular portion of it. So let's try and interact directly with tables. So I can go out and I can create a table. So I've created a table up there using a pattern whereby my storage account name and key are kept behind a service, and I can go out and create tables. But you may want to store data in those tables from the device. So that's quite straightforward as well. So at the moment, I just filled out a list and saved that back up into the cloud and retrieved it back down. So that's interactivity with tables in terms of managing them, creating them, etc., and also storing data. You can also go out and utilize that shared access signature service, which I showed you, to go out and interact directly with blob storage. So to do that, I'm going to go and take a photo using the emulator here. So we've taken that picture using the emulator. Now we're going to, it seems like something's not having quite a nice time here. All right, so I don't have permissions. All right. What's that, sorry? All right. So that, you can't see it here. No. Let's see if I got anything over here. Yeah. There we go. Little coaching from Wade up the back there. Right, so now we've gone and uploaded that blob, but we can also go out and let me change that back to pictures too. Go out and list that back. So what's happening here is it's just pulling on some data from one of the previous, dry runs I did, which has obviously now gone and sort of not worked out the best for me. But now I've gone up, I've uploaded that blob, and I've pulled it back, so I can actually click on this guy, and you can see that now I can go out and render that image back in my device. And if we look at this this URL here, you can see this stuff over on the end that looks a bit bizarre. That's actually our token from the shared access. So yes. Yep.
So you couldn't use this URL
No, not unless you provided a policy whereby it lasted that long, or if you made that blob public. You can make them public if you want them to be, accessed without needing that. So that's probably last one that I'll do here is to have a quick look at utilizing queues directly. So this is where you may go off and offload work. So let's create a queue, and let's click into that. Let's put message 1 in, message 2, message 3. So we're pushing them up, and we could quite literally have a worker role pulling off these guys, but we can also dequeue them from our client as well. So consider scenarios where you could use this for messaging between two separate users, for instance. You could write into another user's queue, which they're reading out of, or a worker role could be doing that as well. So let's jump back to the deck. If you are interested in the this and particularly the push notifications piece, which we didn't have much luck with, I'm more than happy to help you walk through that in the labs tomorrow. It's just we need to sort of move on here now. So that was a device toolkit. Now, let's share this guy. So the other toolkit we have here is one which I created. So there's also a toolkit, Windows Azure toolkit for Windows 8, And this, again, implements that notification scenario. Now, it's got a lot of nice assets if you're going to go out and develop for Windows 8 in terms of the rich notification and templating types for Windows. There's quite a lot of different templates, and we've managed to compress your means by with which you can send these down into 3 lines of code. So it's definitely an asset which is going to save you several weeks of development if you're going to go out and start developing in this area. So I'd encourage you to look at that one as well. So let's move on to gaming. Okay, so gaming. From the game perspective, we've also got a rich array of devices. So we've got iPhone, Android, iOS, we've got browsers, we've got Win8 Developer Preview, and we've got Facebook games as well as an option. Now, some of the features of connected games include, again, authentication. You may want to start storing user settings for these games or state of the game up in the cloud. You may require some form of real-time communication between different clients. And you may need services like a leaderboard to show who's leading and people if they're going out and achieving different things or reaching different goals. You may want something that can go out and provide that for you. So what Nate's gone and created here is the Windows Azure Toolkit for Social Games. Now this provides a whole bunch of reusable assets which you can go out and use or start pulling into your application and learning how they work. So weapons, gifts, achievements, there's a whole large list there. You can probably focus quite quickly on the ones which are of interest to you. But that there is available on wapgames.codeplex.com. So another key thing which this toolkit and the samples within it provide is a nice command query separation pattern in terms of their implementations. It utilizes queues and blobs and REST services. So what does the default pattern look like in this case? Well, you've got a user, and we've got our separation of commands here. So we've got a user, John, and he will write up through the web role, proxying that request to a queue, like we've seen on the device. He will write his move. And then we've got a worker role, which will sit there and pull that move off the queue and process it to determine what the outcome is. That outcome is then gone and written into blob storage, whereby John or other players can then go and see the state of the game. So that's separated out into a big write side of the pattern and a big read side, so command query separation. Now, I didn't intentionally make that look like a love heart, but it just seemed like a good idea at the time. Right, so the other thing to note, by separating it out like this, you can spread the write and read across 2 separate storage accounts, and thereby you're increasing your transaction threshold by 2. So rather than being capped at the max transactions per second of 1 storage account, you've now got 2 storage accounts, so thereby you're increasing the throughput which you can handle. So one particular game at the moment, it is a beta, so the tagline is we're still dusting the sand off the tanks. But if you go to tankster.net, you can go out and play that game. So the full source code for this is shipped within the toolkit, and perhaps we'll have a quick look at a more simplistic application that's also shipped with the toolkit, and it utilizes the same set of back-end services. So let me just pull them up here for you. And I will grab it out of my notes. So this is tic-tac-toe. So that's player 1. Let's go and look at another player. Let's pull him over there. This guy over here. So let's have a look. You can see I've gone out, I've made a move, it's gone, written it to the queue, it's been processed, stuck in blob, and come down to the alternative player. So just bear with me while I try to beat myself here. There you go. So quite a simple example. It's very streamlined on the client side, but it demonstrates that this pattern is quite good in terms of being able to go out and build out different clients that can utilize it. So one being Tankster, the other one being tic-tac-toe. So again, saving you time to go out and implement these scenarios. So let's go back to the deck. Quite a lot of jumping here. I do apologize. So next, just covered social games and the Windows Azure Toolkit for social gaming, and now we've got social apps. So I'm talking predominantly in this space at the moment, it's Facebook. So what do we have here? So why would you want to develop an application for Facebook? Well, the first reason would be you've got an active audience of over 800 million users. So that's quite significant if you've got some application that you want to monetize or create some kind of business model out of. It's also got a broad reach across multiple devices. So, you've seen the clients for, Phone 7, iPhone, web browsers, all different sorts, etc. So you're not just targeting one user that's sitting in front of their computer, you're targeting a whole large array of users across different devices. And if you're going to start considering building apps for these, it's not just games you can build. You can build communication apps which rely on media, TV, news, books, or lifestyle, the typical fitness or recreational type applications. So that's why you would target it. You've got a large user base which you may be able to monetize, and they're the types of apps which you can use. Now, why utilize Windows Azure as the backend to support these apps? Well, the key thing is if your application is going to go out there and it is popular, it may go viral. So you're going to need to be able to scale extraordinarily fast to be able to support that. So let's say you do go and push that out and then you start getting more and more users. Windows Azure, with its elastic scale, is going to allow you to, within the portal, increase the number of instances you have on that web role, thus being able to satisfy the large demand you may be receiving. So focus on code. So that's been one of the key things we've been saying. Focus on building your applications, not managing the back-end infrastructure. Iterate rapidly. So you could have your game up there. It's getting extraordinarily popular. You've scaled it out. You're now satisfying those users, but there's some bug that's there. So you can actually go out, make that change, publish it up, and then swap it out. And quite literally, you're not going to have any downtime doing that. So what kind of tools can you go out and use to develop these? Well, there's several SDKs available out there on the web, on Codeplex and such, which allow you to go and interact with the Facebook APIs without needing to write a reasonable amount of data yourself. So there's JavaScript ones, PHP ones there, and a C# one as well. So here is one particular case study. A company called Thuzy went off and created an marketing application for Outback Steakhouse. Now, so what the scenario was here is Outback wanted to be able to go and encourage their guests to come back in through a social media, a social networking site, this one being Facebook. So their marketing campaign had a short cycle and very clear goals. They wanted to offer anyone who went and liked their page a free Bloomin' Onion coupon for the first 500,000 guests. And they wanted to reach that goal within 30 days. So you can imagine that's a lot of data that you may be collecting during that period. So the first thing, given that I don't live here, that I wanted to know is what is a free Bloomin' Onion? So for those of you that aren't aware of what it is, that's what it is. Now, so that was a scenario, but what was the outcome? Well, they chose to go with Windows Azure. There was no outlay for on-premise hardware. So consider if you're going to have spikes in users, you're going to need to be able to support that type of demand. Now, with Windows Azure, we're able to easily scale to go and satisfy this demand. If you were on-premise, you're just going to need to buy all the servers that you need for whatever you think that max threshold will be. And then afterwards, you've got these servers that you've spent a lot of money on, but you may not be using them after that 30 days. So the solution utilized an asynchronous architecture, some web and worker roles, App Fabric cache, for lookups and such, just to speed up the process. And then it was a sandwich approach with SQL Azure and table storage for some of the reporting and storage of information they were collecting. So it took them 8 weeks to develop this, and it only took 18 days to reach that 500,000 target. So that's quite a good example of if I'd have gone out and said, well, I'm going to get 500,000 fans in 30 days, I'm going to go out and buy hardware that's going to be able to do that. Well, it's quite possible that, given that it all happened in 18 days, that you wouldn't have had that capacity to go out and get those 500,000. You may have only got, a significantly amount less, maybe the 250,000. So being able to scale elastically here is extraordinarily beneficial. So,
can you talk about that scaling process? Do they have to manually see that it's going beyond a certain amount?
Yeah, so this one, there are tools available that allow you to see, or say ping your service and see what the load and capacity is like on that, and then be able to react to that. And that can be both a manual process if you want to log into the portal and increase or decrease the instant count based on those fluctuations, or you could utilize the service management API to automate that for yourself. So, summary, we've covered a lot of content here. Web, technical computing, devices. Again, come see me if you want to see notifications there. Social gaming and social apps. So at the moment, we've actually got something quite special that people in the public haven't seen. So I'm going to invite a very special celebrity guest up on stage, and he'll give you a demo of that. And we'd like to try and, I guess, elicit some feedback from you as to whether you think these things are good. So there you go. Thanks, guys. There's another one right there.
All right, is that working? Good. So since we had a few extra minutes and we knew we had a little bit of time in the agenda, I wanted to share something. Since you guys, I actually wasn't here when Nick asked how many of you had used the Windows Phone Toolkit. Any quick raise of hands? So a handful of people, that's good. You saw Nick demonstrate it, and I'll tell you what the mistake was later. But we've been working on a different way of basically trying to share the toolkits. What you saw with the toolkit, it installed a project template, and it installed all this great capability, but in a very kind of monolithic, hard to decompose example. And so you talk about the shared access signature service, which allows you to get this back and use it for your apps. There was all kinds of authorization built on top of things, and all these things that are hard to decompose. And so I just wanted to give a quick demo to see. And then we don't need to do the feedback here. I'd love to meet afterwards and get your opinions as well. But what your thoughts are to a different approach to doing this. So what I'm going to do is, instead of starting with a big project template, I actually want to go right where most developers would go, and I'm going to go to my Windows Phone app. And I'll just do a new Mango app. And what I want to do, I'm just going to do a very quick demonstration around how to add push notifications to the phone, where the services that both store the MPNS channel that you use to push the message down, as well as the service used to push to MPNS, are run. So that's basically running those services in Windows Azure. And I want to do it in a way where it's very easy, it's lightweight, and it's something that you could just make additive to your existing application. So here's a brand new phone application. What I'm going to do is I'm using NuGet. Does anyone here not know what NuGet is? Okay, I'm going to show you. So NuGet is a way of delivering libraries, code, etc., directly into your project from a repository where things are kind of pre-built and ready for you. So you can see here there's a way to search online and take a look at existing NuGet packages, like if I want to use Web Activator or add NUnit or jQuery, etc., and I can install it. It'll grab the resources, throw it into my project, and now I can start working with it. And so we've built some NuGet packages as well, and what I'm going to do is grab some of those to first, on the Windows Phone side, create the capability to register an MPNS channel, and then also the ability to get a message sent down to the phone. And so I'm going to grab the appropriate package. Let's see which. This is where I always get lost, I can't remember which one. The reason we have so many is we're trying to make these extremely composable so that you can use some of them, or you can use all of them, or you can use one, et cetera. So there's a lot of different ways to use it. So I'm going to use this one here. It's the Microsoft Push Notification Registration Service Client for Windows Phone. We also like really long titles. So I'm going to install that. And you can see here, it's actually grabbing all these resources, and it's going to throw them into my project. So now in my project, I've got not only some documentation, but I've got a notifications page. And the notifications page gives me the ability to actually create the MPNS channel. So that's the channel that then folks can push the message down to the client. Now I'm going to do one thing here as well so that from a demo purpose it's quick and easy. I'm just going to change the default page that gets loaded. So I'm going to go pages, I believe. Pages / notifications page. Now in Mango, we also added the ability to deep link from a toast notification. So I also want to create a new page, and oops, not existing, create a new page. And I'm going to call it deep link XAML. Yes, I was worried that I wouldn't remember the name. And I'm going to add to it is that the right spot? Yeah. Some code. So here's so basically a text block. And then on back here, there's also a method that we're going to add that is the onNavigated_to that uses the system.windows.navigation. So essentially, when a deep link is received by the application, it's going to grab the message out of the query string from it, and then it's going to display it into the text box. So that's it. So that's really all I'm doing. Very little bit was added to it, just basically some code to handle the channels. So now the phone app is ready to go. What I need to do now is create a service that's going to handle the registration of the MPNS channel, and then it can also send the message down to the phone. So I'm going to add a new project. And this time I'm going to choose a Windows Azure project. And note how I'm not using any sort of special project templates. I'm using the tools that come with the SDK, and I'm just augmenting it with resources through NuGet. And here I'm going to go up to my web role, which is just an MVC app. Oh, I did not choose an MVC app. Let me do this. Add new web role, MVC3 app. I'm sorry, I missed a little bit of Nick's. Maybe he didn't go in it. So essentially with when you want to send a push notification down to a phone, you're not doing any sort of active polling. So you're actually going to have a message sent down to the phone. And in order to increase battery life and kind of keep random people from opening up sockets on the phone and listening, we have a service provided. Microsoft has what's called the Microsoft Push Notification Service, MPNS. Apple has Apple Push Notification, APNS, Android has C2DM, Windows 8 has the Windows Notification Service, and so, MPNS. Okay, I forgot what I was doing. Let's see. Okay, so I'm going to also, I'm going to remove this guy. All right, so now I've got my MVC web role. What I'm going to do is add some NuGets here as well, actually just two. I'm going to add, I just went through this and showed Steve, and I couldn't find it then either. Let's see. This guy right here, the Microsoft Push Notification Service Recipe. Nope, that's actually the base library. Next time I'm going to name them 1, 2, 3, 4, and 5. There we go. Sorry. Microsoft, the Push Notification Registration Cloud Service. Okay. And notice that it also has some dependencies it works on. So we're actually creating a web API, which is a type of WCF service, but much more flexible than you'd think from a traditional WCF service. And so it's going to install some of those dependencies as well. So they are chained. So I'm going to have to then also accept their terms of agreement. Add all of this, and essentially these are going to be all the services that will be used to store the channel URI that we get from the Microsoft Push Notification Service. And we're going to be storing it in Windows Azure tables. So there's that. Now the last thing is right now I don't have any kind of client or UI or anything to actually generate the notification. So actually create a message of some sort of text and send it down to the client. That's the whole web UI that Nick showed you where he was going to try to send the channel or send the message down through the channel. And so we also have created just a very simple sample where you can register an MVC area with the so it's push notification sample management UI, and it creates an MVC area where everything's self-contained, but it allows us to tap into the service that's running now in Windows Azure. All right, so we've got those things set up. The last thing I'm going to do is just in my service model, I'm going to do a quick update on the endpoint, and I'm not sure why it's 8080, but we're going to make it 81. And let's give it a whirl. I feel like I missed something. All right. So what it's doing now is I'm running it, and it's going to run the it's going to run the compute emulator for Windows Azure and run all of our services there, and it's also going to open up the phone emulator as well. So let's get this started. And you'll see we've got our phone app here. And as soon as our website starts, I'll open up the phone. And so since we added that MVC area, we have this notifications landing page that we can use to send out push notifications. So I'm going to open up the app, and the first thing I'll do is I'll enable notifications. So this will contact the MPNS server, get a channel URI, and then once it gets the channel URI, it's going to send it up to the web API running in the Windows Azure, and Windows Azure will register and store that for us. So now if I refresh this page, we should see the registered channel URI, which is with our phone app 8, and it is an anonymous user since we don't have any sort of login mechanism here. And so now that that's registered, let me scroll out on this a little bit. I'm going to send a notification type, and I'm going to choose a raw. There's 3 notification types with Windows Phone. There's raw, toast, and tile. Raw lets you actually send a message directly into the phone app. And so you can see this message right here, let me send it again, was sent directly down into the phone, so raw 2. So that actually means like any user that's running the app, if they receive this raw message, I'm going to be able to inject some sort of update or do something to send them some information right into their application. So that, I think, is pretty neat. However, I can also, from this experience, if I've pinned this to start, can also try tile. And with Mango, there's a bunch of updates. So I can say title. Let's say this is 12, and I'm going to choose a background tile. So you can see here it's going to update. It's going to update the background tile. It puts a status of 12, and it changed the title. So we're able to affect that experience right there. And then lastly, I can send a toast. Let's first just send a standard toast. So we'll just title, subtitle, and so we're going to see that up here. And then now let's send a toast with a deep link in it as well. And then target page. So essentially what you do is you have to specify what the page is within the app, and then you'll see how it basically has this query string parameter attached to it, like message equals, and then what you want to send. And so I'm going to send that. So it's been sent down, and when I click this, it should open up the app, and yeah, sorry, this is not very good UI update, but you can see the word hello got written in there. So the only reason I wanted to very quickly show that is I knew we had a little bit of time, and I'm very curious about what you guys think about composing these sorts of experiences to leverage assets in Windows Azure rather than going the kind of monolithic approach where, hey, here's a project template with all kinds of samples that has everything you might think of, but you really only want that one little piece. So just something to think about, and then tomorrow you can ask any of us about it or chat with me. So thank you very much for the little interruption. So.